Before I talk about more details about this, please do me a favor. Can you write down it as your digital notes? Who, okay, what or who is the HACCP, HACCP, the HACCP, the supervisor in your country? In Taiwan, there are two. The first one is Taiwan FDA. The second one is Taiwan, the Ministry of Agriculture. And please search for this. And please, the competence authority of HACCP in your country. Please search for this. In Taiwan, there are two. The first one, is Taiwan FDA. Okay, I try. The Taiwan Food and Drug Administration. And the second one is the Ministry of Agriculture, similar to USDA. For example, the USDA, U.S. Department of Agriculture. Okay, then they also in charge of some HACCP. Please take 3 minutes to finish this part. Who is or what is the supervisors, the national supervisor in your country to handle HACCP? Oh, okay, let's move forward. Okay, forward. Okay, the HACCP approach. Okay. Here, HACCP goes beyond inspecting finished food products. Again. Generally, we think about as long as I do a good job in a finished food product inspection, but actually that's not the steps. For example, it helps to find, correct, and prevent hazard throughout the production process, not only checking the final product, but they can learn about the preventable hazards, try to minimize hazard during the process. That include physical, chemical, and biological hazards. Okay. And there are 7 universal accepted HACCP principles. Every country that uses HACCP follows those principles. The principle 1, hazard analysis, and this step, the first 7 steps, it means try to establish the theory, but the last 5 digits try to make it practical. Okay, here a plan is laid out to identify all possible food safety hazards that could cause product to be unsafe for consumption. Okay, all possible reasons. Then they will screen out the less possible or the less severe factors. Okay, and the measures that can be taken to control those hazards. For example, the cooking step is one of the production process. One of identified hazard that is survival of pathogens due to the inadequate cooking time or temperature. Thus, the cooking is a key step, and we call it critical control point. The principle 2, identifying critical control points. Okay, here again, what does it mean critical control? Because it is critical. Important, that is not assumed. Important, the term is important, but the critical is very, very important. Get it? And it's impossible to control all steps, all procedures, all points in order to make the food be safe. It's impossible. Thus, we just try to control the most important, we call it critical control points, in order to minimize the hazards. Okay, here, critical control points are the points in the production process where an action can be taken to prevent, eliminate, or reduce a food safety hazard to an acceptable level. Here, who can tell me why? For example, you can kill all the bacteria, all the fungi. Why you say to an acceptable level? Who can tell me? Why? I have a second microphone. Okay, who want to tell me? Tell me? Why? To the acceptable level. Because on the presenting day, I will hold one microphone and you will hold another. The student will hold another. Okay. Why? You can kill all bacteria, all fungi, all microorganisms, all viruses. Why it emphasized to an acceptable level? To kill all bacteria, nothing left. All bacteria will be killed. They should be in dead or something like this. Okay, I agree with you, but it's economically invisible. Because when we kill bacteria until no bacteria or no any microorganisms survive, it's impossible. If you can do this, but you need to pay a lot of money. Get it? For example, if I cook or roast a beef, wow, it's delicious. Or I am going to prepare a hamburger. It's impossible to treat the food as a sterile, you know the term sterile. Sorry. Maybe my accent you cannot recognize it. Sterilization. Sorry. Sorry, sterilization. Okay. Oh, sterilization. The act or process of sterilizing as here. Okay. The rendering something free from viable microorganisms. In my easy explanation, kill all microorganisms. Okay. Sterile. Condition of one of sterile. I should. Okay, the definition is here. Sterile, I prefer. Free from living organisms and especially pathogenic microorganisms. And sterile, in our language, I'm for the microbiologist, we very care about the term we use here. Sterile means no living microorganism inside. For example, if you brew a cup of tea, that is through the 100 boiling water, the 100 degrees Celsius. It can kill many bacteria, but it cannot kill bacteria with spore. Let me show you the spore. Okay, here endospore. Endo means inside. Spore is a kind of structure. So kind of structure. And here is the picture. The name of this picture. This picture is Bacillus subtilis. Bacillus subtilis. That is not English. That's Latin. Latin. Is a scientific name for organisms. And you can see the green spot here. The green spot is the spores, because it's different from, let me explain this, because of my master research, when I was a master student, I did some research about the Bacillus subtilis. It's a kind of natto bacteria. Natto is a famous traditional food made from soybean, steamed soybean in Japan. And some Japanese think that, most Japanese think the food is delicious. But some Taiwanese think the food is horrible, the stinky, something like this. Okay, you can see the green part. Green part is a structure in the cell. It's different from the mold. When it's very humid, and you see my shoes. It grows a lot of mold, and you cannot wear it again. Okay, or you can, if I have cake or toast. Or bread, something here. I forgot to eat the toast, and 2, 3, or 4, 5 days later, we can see a lot of mold on that. That kind of spore is different from this spore. That's exospore, this endospore. Okay. When the bacteria feel stress, feel living difficulty, then it triggers its living process. For example, oh no, it's dry, it's very dry, or it's no more food here. We need to protect ourselves. Then the bacteria here try to replicate the DNA, one more copy. and try to surround the DNA with extra materials, and the materials is very strong, resistant to heat, UV lights. For example, when we cook, maybe the temperature is reached to 100 degrees Celsius, but it's not enough to kill the spore. After that, okay, wow, it's easy. The stress is passed away and the environment looks okay. Then the bacteria, the vegetable cell will be dead very soon. But the gene, the DNA, is inside of the endospore. When the environment is friendly, another food, the temperature okay, and no more UV light, then they can be alive again. So I really, because of my master research, I did something about this. So I'm familiar with this. Okay, let me give you this. Yeah, go ahead.
In human body?
This one,
Yeah.
possibly, because and this bacteria is good for us. That is good for us. But sometimes, Bacillus, there are many variations, different. For example,
Like in Yakult.
okay,
Like in Yakult, it's a good bacteria.
bacteria. Let me show you here. Okay, Bacillus subtilis. This guy is good for human, but his brothers is not some brothers is not good for us. Let me show you here. Okay, here endospore can survive without nutrients. They are resistant to UV radiation, desiccation, very dry, at high temperature, extreme freezing, and chemical disinfections. Wow, you cannot kill it. It's very strong, very resistant. Okay, that is one thing. And one good situation here. Do you know this guy? Bacillus cereus is one of pathogen, food pathogen for us. I don't know the translation in your language, but in our language, we have a different translation of this one. This is the food pathogen. It can produce the endospore too. Bacillus anthracis, you know the term, it's dangerous, very dangerous, because about the year about 2000 or 2001, the terror attack to the US, they put this bacteria into the powder into an envelope and sent envelope to US, and it killed maybe 2 or 3 people. It's terrorism like this. And Bacillus anthracis, and this microorganism can produce endospore too. Thus, it's very dangerous. Okay. Then let me show you here. And here, Clostridium botulinum. For example, if our canned food, fish can, chicken can, beef can, the kind of can, if the process is not complete heated, maybe the survived Clostridium botulinum will kill us. Let me show you here. Botulinum is a diverse group of pathogenic bacteria. Initially, they were grouped into like this one. Okay. Botulinum toxin can cause botulism, the severe flaccid paralytic disease for human and other animals, like this one. Okay. It's commonly associated with bulking canned food. If the can cannot heat it very well, the botulism can be happen. Mishappen can be due to the internal increase of pressure caused by gas produced by bacteria. It is one. Sorry, it's one. Like this one. Okay, so let me come back to here. Come back here. And again, my question is why I said to acceptable level. Here. Here. Why? Because it's impossible for our kitchen, our family kitchen, to kill the bacteria. It's impossible. It's impossible. We have autoclave. Autoclave is very high pressure steam to kill the bacteria, all bacteria. If you have chance, if you stop by with the biology lab on the F floor at 110, at 10, the B at 10, the classroom, you can take a look at that. And that is able to kill all bacteria. All bacteria. Okay, let's move to next. Principle 3, establishing critical limits for each critical control point. Okay, critical limits is the limit which a hazard is acceptable without compromising food safety. That is okay and no compromising for the food safety. For example, critical limits at the cooking stage, including specific time and temperature for cooking for the product. Okay. Then, principle number 4, establishing monitoring procedures for critical control point. Highly detailed monitoring activities are essential to make sure that process continues to operate safely within the critical limits. Each control point. For example, monitoring procedures at cooking, the critical control point could include taking the internal temperature of the product with a specialized thermometer. Okay, I will explain it later. And actually, HACCP is very complicated. For example, if my company is producing, sell the frozen raw seafood, and it's impossible to cook, you know that. But how can you conduct the HACCP process? Get it? Okay. If my company, $1 company, is about the vegetable and food transportation, can you cook it? No, you need to deliver the raw material to the supermarket. So how can you keep safe? How can you set the critical control point? How can you set the critical limit? Tell me. It's impossible. But the same situation, for example, a company is selling the frozen raw seafood. The control point is the time and the maybe minus 20 degrees Celsius. They need to control this, because after they highly control this point, they deliver their product to the a hotel, a restaurant, or for the process, for the manufacturer. They got the frozen materials. They try to defrost, then make their own foods. And during the process, on very low temperature, the bacteria may not grow under the harsh condition. So again, HACCP is very complicated, very, trust me, very complicated. But we can use different way to observe it. Okay, principle 5, establishing corrective actions. Corrective action. What does corrective? It means when something is wrong, or the trend is going very close to the wrong situation, we need to take actions. And the action is called a correction or corrective actions. They are different. Again, correction in HACCP, it means they focusing on one event, but corrective actions, it means they try to solve the problem from the system with a systematic view, not only one event. Not only one event. For example, when I walk here, every time I didn't notice the gap here, then I fall down. For once, okay, I fall down, then okay, I not got hurt, no problem. Correction is okay. But every time I come to this classroom, I didn't notice that, then I fall down every week, twice a week, and we need to solve this problem. Then we set a slope, a steady slope here to prevent the lecture fall again. That is corrective actions. Again, correction in turns, it means try to solve one event once. Corrective actions try to prevent it happen again. Okay? It's not easy, at least for we Taiwanese, we cannot understand the details of this. Okay, then next. Actions must be taken to bring the production process back, and track and monitoring indicates that deviation from the critical limits has occurred. In food production, correcting problems before end stage production is far more effective than waiting until a product is finished to test it. For example, if the required internal temperature has not been reached, assume we set the temperature to 80 or 90 degrees for cooking. A corrective action will be required that the product will be cooked further, more time. If the cooking temperature cannot be reached, another corrective action will be called for the product, because will be called for the product to be held or destroyed. Okay, if cook again cannot reach the temperature, maybe stove is problem, the energy, the electricity, or the gas supply is a problem, or there's something wrong with the air supply, because many restaurants they use the air supply to increase the temperature of the cook. Okay, principle number 6, establishing verification procedures. Here, in our accent, verification, but in the American accent, verification. Okay, verification, that is very, very hard to understand. For you, maybe you are English learners, you verification, not easy, but the concept is very, very hard, because there are 3 terms. Let me show you here. In HACCP, there are important concepts like this. Okay. I know for most of you, those 3 words are not easy. English words, okay, I can learn. No. You don't know that. The first term is validation. In HACCP system, what is in validation? Second one, monitoring. And third one, verification. No matter the translation in your country, let me do it, because it confuses for many Taiwanese, including students and some consultants. Some consultants, their quality is horrible. Okay. Here, validation, what does it mean? In HACCP system, your passport is invalid. it means my passport is out of date or something like it, or something information wrong. It's not a useful one, invalid. And okay, if I bite a light tube or light bulb here, I want to buy that to replace the old one in my home. Can you bring it home? Then you find the one I bought is a broken one. It's impossible because in Taiwan, when you bite a light bulb in the supermarket, there is a socket. You can test the socket to make sure your light bulb is working. Okay, and this process is called validation. And the key words of this is before. Your background is business. You don't need to know too much details about this, but you can take a look at this. What is monitoring? Monitoring is okay. Monitoring, the key words is during. What is the verification? What is verification? After. Okay, let me type those three. Let me have another example for you. If you plan to drive a car, before you drive it out to the parking lot, what do you know? What do you need to do? First, check the gasoline. If the gasoline is okay, check the tire pressure. I have 4 tires in the car. It looks okay, but prevent the flat tire. Okay, that is before. You need to do that before your departure, before your journey. It's validation. What's the monitoring? When I drive, strange noise from my engine, or some crashing sound from my back truck, something like this. You need to monitor it. What is verification? I check the mileage. Wow, it's 20,000 kilometers. I need to replace the lubricant. Or I need to enter the garage for annual maintenance, something like this. And that's a verification. In the future, if you have a chance to enter a food company, they have implemented the HACCP system. You will remember my words: validation, monitoring, and verification before, during, and after. Let me show you this. Okay, okay, let me. What's the difference between HACCP verification and validation? What's the difference between monitoring, verification in HACCP? Okay, let me check this one. Okay, somehow we mean by validation or verification? Validation is a process to determine critical points are required in order to control the hazard has been identified. Verification is the process of checking the critical control. Can you understand? No. It's not about the language or English. It's the concept. It's not about the language. Okay, again, validation is a process to determine the critical are required. That is usable. For example, in a kitchen, it decided 80 degrees to cook. You have a thermometer to check. You cook the chicken, you cook the turkey. If you set the 80 degrees inside internal temperature, is it okay?
Yes.
I don't know. I don't know. Okay, if you set the 70, if you set the critical control point is 70 for 1 minute, is it okay? If the 80 degrees for 2 minutes, is it okay? Or you can set 60 degrees 1 minute. Because the more heating, maybe the flavor is decreasing. Okay, let me show you here. Oh, I had the echo. Okay, so there is one way to do the, let me show you here. Here. Food safety.gov, cooking to save the minimum cooking temperature. Okay, and here there is scientific research evidence. So we can trust beef, bison, veal, goat, and lamb. The minimum temperature, internal temperature, not the surface temperature. The surface can be very hot, but the internal temperature is lower. Rest time 3 minutes. The minimum 63. Okay. Chicken, turkey, that is 34 degrees Celsius. Time is not important. So if you set your temperature, your cooking temperature to 60 for the turkey, for the kitchen, is not safe. If you cannot set your step to a reasonable or safe step, it's useless. And the validation, it means try to understand, pick up a useful method that is working. Otherwise, it's useless. Validation means before you cook, before you start your business, before your kitchen, before you cook your dish, you need to pick up a reasonable control point with scientific evidence. Here, this website is from USDA. The food safety.gov, created by USDA. The title is minimum cooking temperature for safe. Okay, chicken, turkey, and other poultry, duck, something like this, or goose, geese, right? Minimum temperature 74. But how about beef? Beef is 63. How about can I use 50 degrees to cook it? You can cook it, but when you diarrhea, it's your business. It's not our business. But for cooking, for family, or for your business, this is the basic requirement. Okay, and let me come back here. So establish verified procedures. Verification means applying methods, procedure, tests, sampling, and other evaluations in addition to monitoring to determine whether a control measure is at the control point is or has been operating as intended, as your plan. Verification activities also ensure that the monitoring and the corrective actions are done according to the company's written HACCP program. For example, test and calibrating thermometers is a verification procedure that is important to ensure accurate readings. if your thermometer, something wrong with the reading, for example, it's now is 80 degrees, but your thermometer shows now it's 85, but the error is 5 degrees Celsius, it can be dangerous. It can be a dangerous situation. The easiest way to test a thermometer accuracy is by submerging the probe into a pot of boiling water. If it doesn't read 100 degrees Celsius, then the thermometer must be adjusted to read the correct temperature. No, actually, when can we read it? Only close to the sea surface. Only close to the surface. I calculated that in China University, the altitude is about 100 meters. 100 meters. In the high mountains, the boiling temperature is decreasing. It's decreasing. Next time I will show you. There is a mountain. Let me show you. There is a mountain called Ali San, Mount Ali, and the altitude is about 2,200 meters, sorry, not kilometers, meters, and the boiling temperature for pure water is 90 degrees to 93, 92 to 93. Okay, next time I will give you the pictures about this. Then I did experiments because I'm going to write a book about the thermometer calibration. Okay. Okay. Sorry, a little bit over the time. Any question? Okay. No more. If you have any question, please like me. I'm always on the group. Okay. See you next time. See you next time.